Algebra Test Review 1-1, Linear Functions and Domain and Range. I'm going to go through a few of the example problems, some of the main focus points, and then you can go back and check the key with your answers on Canvas. There's a PDF format of the entire key. We are going to first start with number 1. A florist charges $24 for a vase plus $2.50 for each Gerber daisy in an arrangement. What will be the total cost in dollars of an arrangement that contains 10 Gerber daisies? So in order to solve, we're looking for an equation first. So we need to pick out our important information. We need to know that it's $24 for a vase and $2.50 for each Gerber daisy. Okay? When you're writing this equation, whenever it's telling you for each, that tells you that your constant rate of change, because each one of the daisies costs $2.50. So we're going to say that y equals $2.50 x, because that's what it's changing by, $2.50 for every additional daisy that's added. Okay, but you have to start out with $24 for your vase. So we're going to add a $24 vase. So now that we have our equation, it wants to know what it would cost for an arrangement with 10 Gerber daisies. Gerber daisies is your input value or the independent variable. So we're going to plug that in. We have y equals $2.50, and we're going to buy 10 of those plus the $24 vase. $2.50 times 10 is 25 plus the $24 vase. So the total cost should be $49. Okay, let's move to the next page. We're going to go to number 5. In physical science class, Ernie discovered that a 4-pound weight stretched a coiled spring 14.2 inches and an 8-pound weight stretched the same spring 28.4 inches. Based on these two observations, he determined that the spring's amount of stretch varies directly with the amount of weight applied. So, important information. We have a 4-pound weight is 14.2 inches. And an 8-pound weight stretches 28.4 inches. Okay, they tell you that it varies directly, so you can set up your y equals kx, and we can solve for k is what we're looking for. If you divide both sides by x, now remember, we have k equals y over x. With this formula, we can use it to figure out how much does the spring stretch per pound. Okay, so let's start with our first ratio. We want to know 4 pounds and 14.2 inches. Okay, we need to decide which one is the y value and which one is the x value. So which one is our input, which one is our output, okay? It depends how much weight I put on as to how much the string will stretch. So we're going to plug in here because it says per pound. So I'm going to put 14.2 inches for 4 pounds. And if I divide that out, I end up with 3.55. So 3.55 inches for 1 pound. Let's check. They told us that it varies directly, but we need to double check that the second one works as well. So we're going to say that 28.4 inches for 8 pounds. And if you work that out, you will get 3.55 inches. Okay, so if you look back at your equation, it says write an equation to show the direct variation. That's what we looked for, the y over x. between the weight applied and the distance the spring stretches. So we found that my K value is 3.55 inches. So if I'm plugging that into my equation, I get y equals 3.55x. And part C, what is the weight in pounds that will stretch the same coil 106.5 inches? So looking at my equation, y equals 3.55 times x. 106.5 inches. I need to decide if that is my x value or my y value. I want to know how much weight is applied to get to 106.5 inches. So I'm going to plug in 106.5 because that tells me the inches. It depends on how much weight is applied to how many inches the coil stretches. So now I have a one-step equation solving for x. I'm going to divide both sides by 3.55. And x should equal 30 pounds. Okay, let's move on to number 9. Next page. Find the value of each function if y equals 3x plus 4. Okay, each of these are giving you either an input or an output value, or your domain and range, and all you're doing is solving. So let's do A. I'm going to take my original equation, my function, y equals 3x plus 4, and it's telling me that my domain is 3, so substitute 3, y equals, substitute 3 for the domain. 3 times 3 is 9, plus 4 is 13. So my y value, or my range, is 13. It works the same way. If you're given the range, you can solve for the domain. So I'm going to plug in, I'm going to start with my original function, and I'm going to substitute 19 for y, or 19 for the range. Okay, two-step equation, subtract 4 from both sides. I get 15 equals 3x, divide by 3, and my input value, or my x, is going to be 5. Number 12. A paper airplane was thrown from the top of a tall building. The height of the paper airplane above the ground can be found by using the function y equals negative 1.5x plus 60, where x is the time in seconds and the airplane has been in the air. Okay, we need to understand what y equals negative 1.5x plus 60 means. So if you were to graph this, if you had your x and y, your 60, a positive 60, is your y-intercept. So we're going to start up here. We're going to start at 60. And then I have a negative slope, so that tells me that it's decreasing 1.5 by 1 each time. So I've kept going, and because it's a negative slope, I'm going to do something this direction. Okay, that's probably not an accurate slope, but it is giving me an idea of what's happening. Okay, and right here down at the bottom where I'm hitting the x-axis, that's telling me when the airplane hits the ground. Okay, and I know that it's going down 1.5 feet per second. Okay, so I'm looking at how many seconds will it take for the paper airplane to reach the ground. Okay, by reaching the ground, if I'm looking at this ordered pair right here, I'm looking for at what value of x is my y 0. I'm looking for the 0 for this function. Okay, so I'm looking, what can I plug in for y in order to get, what can I plug in for x to get y to be a 0? So I'm going to plug in 0. I want my y to be 0 so that I know when the paper airplane hits the ground. So I'm going to solve this equation. I'm going to subtract 60 from both sides. And then divide both sides by -1.5. And x will equal 40. So it will take 40 seconds for that airplane to hit the ground. Okay, let's turn to the last page. We've got 2 more that we're going to work on. Let's do number 16. A ship that is 216 kilometers away from the port is traveling towards the port at a rate of 12 kilometers per hour. The ship's distance, d, in kilometers from the port can be represented by the function d equals 216 minus 12t, where t is the hours the ship has traveled. Find the domain for this situation. Okay, so domain, first of all, you need to understand domain is the input values, or your x's. Okay, and if you're looking at your equation, it's not represented by x and y. It has t and d. So you have to decide which one is dependent. Okay, it depends on what happens at t to tell me what I get for d. So my domain is my input, or t. Okay, and if you think about it as a graph, just like what we did in the last problem, we looked at it on a graph. I'm starting at 216, and it's decreasing. I have a negative slope, a -12. I decrease 12 each time, so my slope is going to be something in the negatives. Probably not accurate slope, but it's decreasing. Okay, and I need to decide what are each of my input values. Okay, but it also gives me a parameter. It says that they're going 12 kilometers per hour. Okay, that's your negative t. That's your slope. Okay, and you can start plugging in values to figure out when you're going to get to the point where you're at the dock. So you can't go past the 216 kilometers because that gets you back to the port. Okay, so you have to decide what numbers can I plug in order to make this work. So if each time I'm subtracting 12, I need to figure out how many times I can subtract 12 before getting to 0. And repeated subtraction is the same thing as division. So 216 divided by 12 will tell me the number of hours it will take. And 216 divided by 12 is 18. So you are 18 hours away from port. Okay, you can't go any further than 18 hours because you can't travel a further distance than to 0. So it should be answer C. Okay, the last one, let's do 20. I'm sorry, let's do number 22. Let's do number 22. All right, looking at this, we need to write an equation from your table. First, you need to be able to identify the slope, or the change in y over change in x. So our change in y is a +6. Our change in x is a +4. So y over x is 6 over 4, which simplifies to 3 over 2. So our slope is 3 over 2. Right now, I don't see anywhere that has an x value of 0, so I need to figure that out. So my slope right here tells me if I change my x value by 2, I change my y value by 3. So if I go 2 steps back from 2, I end up at 0. And if I do 2 steps on the x, I have to do 3 steps on the y, which would put me at 3. So now my y-intercept is 3. So you should have y equals 3/2 x plus 3. Check your answer key on Canvas, and good luck.